All right.
So, honors geometry, great to be back with you guys.
It's been a crazy
it's been a
few
long
weeks.
time. It's been a crazy few weeks.
Looking forward to seeing you guys tomorrow.
But I'm glad to get going again. I'm looking forward to seeing you guys all tomorrow.
Construction on my house.
They're actually doing construction on my house sitting in my car as I do this video. Kind of noisy inside, so I'm actually sitting in my car right now as I do this. So bear with me. So bear with me. I'm excited to get going. Slightly in the background. I'm doing it to get some heat. We were right in the middle of Conics. But anyways, if you remember, before we were together, we covered. We were working on Conics. We looked at ellipses. We looked at hyperbolas. Today we're going to get into parabolas. But I thought it might be helpful, given it's been a couple weeks since we've actually looked at any of this. And also somewhat quickly, just so we can kind of remember their formulas and about. I know it's been a while, and then how they are a little bit different than parabolas, because everything's kind of similar, and I know it's pretty easy to get them confused. So anyways, okay. So let's jump right into it. So an ellipse, if you remember, was a conic, where the sum of the distance between
of the distance
2 points called the foci.
No, I'm just trying to do a video.
Every what is the same.
And the noise.
It's
all good. No, don't worry.
Yeah, okay.
No, I'm just hanging out. It's kind of noisy.
Okay.
It's all good.
The ellipse. Okay. So any point on that ellipse was the same distance, or I should say, the sum of the distance between any point on the ellipse and the foci are the same. So I'm just going to maybe to the right, maybe just remind you what it looked like. If we draw our x and y axis, kind of looked like an oval, right? It's kind of an oval like that, and we had vertices, right? This would be considered a horizontal ellipse. We had co-vertices, and then the foci were somewhere right in the middle. All right, so they're kind of like these oval shapes. Okay, and if you remember the formula we used, right, was x squared over a squared plus y squared over b squared is equal to 1. Okay. Okay, this would be considered, this would be considered a horizontal ellipse. Okay, and then we would also have a vertical ellipse. Sorry, I'm just rusty for me too. X squared over b squared plus y squared over a squared equals to 1 was our vertical ellipse. And again, how do we distinguish whether it's a vertical ellipse, or a horizontal ellipse? Is that A is always bigger, right? A is always bigger. Okay, so for example, if you had something like x squared over 4 plus y squared over 9 equals 1, you know that's a vertical ellipse because the A is under the y. Since the A is bigger, that means it would be a vertical ellipse with a vertice at 3 and -3, right? The foci, right? If you remember the foci, okay, they were either at 0, comma, plus or minus c if it was vertical, or plus or minus c, comma, 0 if it was horizontal. So vert, horizontal. Okay, and then remember, how do you find c? C was just equal to the square root of a squared minus b squared. So it's important you can differentiate between what a is and what b is and actually find those values. That will help you find the foci. And then we also had the eccentricity, which is basically how smushed it was. And we found it by just looking at the ratio of c over a, right? Looking at the ratio of c over a. Okay, so that was our basic ellipses. And again, if you want some more details, you can certainly go back to any of the work we've done and review that. Hyperbolas, that's what we covered the day we left, that crazy day. Where all that stuff happens. But anyways, so this might be helpful to review too. A hyperbola was a conic where the difference between the distance between the 2 points called the foci and every point on the hyperbola is the same. So if you remember, the ellipse was the sum of the distance. This is the difference, or really the subtraction of the difference, right? So the general formula for hyperbolas was x squared over a squared minus y squared over b squared is equal to 1. Actually, let me take a step back real quickly. What did it look like? They kind of look like these mini sideward parabolas, right? And we actually graphed in these slant asymptotes that those hyperbolas followed. You could also have, let me change some colors. You could also have potentially vertical hyperbolas like this. We'll differentiate between them in a minute. But you'll either have the red hyperbolas or the black ones, right? So you have the ones in red would be vertical, right? This would be considered vertical, and the ones in black, we would call those our horizontal hyperbolas, right? So we covered that. So when we had something like x squared over a squared minus y squared over b squared equals 1, if the x came first, okay, we would consider it horizontal. Okay, be considered horizontal. If you remember previously, how did we figure out if it was horizontal in ellipses or vertical? It had to do with the a and the b values. When it comes to hyperbolas, we're going to look at where the x is placed or where the y is placed. So conversely, if we wanted to look at the formula for vertical hyperbola, our formula is y squared over a squared minus x squared over b squared equals 1. This should be considered a vertical one. Notice that the a squareds and the b squared stay in the same place when it comes to hyperbolas. So the way we differentiate, right, is which comes first. Does the x squared come first or the y squared come first? And that will tell us the difference between a horizontal and a vertical ellipse. Okay, just like in ellipses, foci, I'm sorry, I'm having trouble right now writing on the iPad. I'll get better. The foci would be at 0 plus or minus c if it were vertical. Remember, vertical always lie on the major axes. And if it's a horizontal, it's going to be plus or minus c, comma 0. That's if it's horizontal. Okay. Remember, okay, that on these, the foci actually lie outside. Okay, the foci lie outside. Where an ellipse, they lie inside, right? So, for example, they might be right there, okay? So the foci do lie in a different place, but they still kind of take that same general idea. How do we find the foci in hyperbolas? Well, we use this little mini formula. C was equal to the square root. Remember in ellipses, it was a squared minus b squared. In hyperbolas, a squared plus b squared. One of the tough things about conics is there's a lot of formulas to memorize, and we can derive them, and we've derived, I believe, a few of them, but intuitively, they're similar, and they're also just very close. So you just really have to pay careful attention to the details. Okay, eccentricity, right? Just like we had eccentricity for ellipses, we can have them for hyperbolas. It's basically how skinny or how wide those little mini parabolas are, found the same way, c over a. But what is additional to hyperbolas, if you remember those asymptotes, we want to be able to graph those asymptotes too. Okay, there were two mini formulas for those. Y equals plus or minus b over a. We use that if it was horizontal. And then we use y equals plus or minus a over b if it were a vertical hyperbola. Okay, so there's kind of a lot there, and again, go back and do some of those practice problems and review some of that stuff if you feel like you need to do so, okay? We're going to do some more. We're going to do parabolas today, and then tomorrow we'll take some questions in class, and then we're going to just do review of everything all at once. So you won't have to necessarily worry about that, okay? But let's get into something new, okay? Parabolas. Okay, let's get into something new. Okay, you may have seen parabolas before. Okay, you may have seen parabolas before. They take, right, the general, they take the general shape. Let's see how good I can draw a parabola here. Not bad. It takes my general parabola shape. There it is. But what actually is a parabola? Right? What makes a parabola a parabola? Well, what makes a parabola is that the distance between a singular point, okay, not on the parabola, called the focus. So we've seen that point many times before. And a line, also not part of the parabola, called the directrix. It's direct and then trix. Directrix is the same. Okay, so it's a little bit confusing. It may be more helpful to kind of maybe draw something out here. Let me go with green. So we know we have this line. Okay, I'm going to draw this down here. And it's always going to lie below the parabola or above if it's facing down. That's going to be my directrix right there. Okay, so it says that the distance between a point on the parabola, okay, and the directrix and the focus is the same. So I'm going to put, there's my focus there. And what it's saying is that the distance there, I did not do a very good job in drawing this parabola, because you'll see in a minute it's not going to look the same. So Katie, you're not going to like this. But those two lines I drew, the line going straight down, okay, and the line, let me do this in black. So those two dotted segments I drew in green, where I put those little dash marks, they're supposed to be the same. I did not do a very good job drawing that. But those two would be the same, okay, in a parabola. Okay, I know they don't look the same. Again, you can shoot me for it later. But those should be the same. Okay, the only thing I do want to mention is that this line down to the directrix, okay, it should be perpendicular. There's that perpendicular sign to the directrix. Really, it should be dropping straight down. Okay, should be dropping straight down. The other segment, this one right here, doesn't need to be perpendicular or anything like that. You can just draw a straight line between those 2 points. But when we talked about going to the line, the directrix line, it must be perpendicular. Okay, so just watch out for that. The other thing I just want to mention is that the distance, let me use a different color here, between the focus and the origin, we're going to call P, okay? And then this distance here should also be P, because again, the distance between the focus and a point on the curve, right? Let me overdo that in black. We're going to call that distance between the focus, okay, and the origin, and then the origin and the directrix, we're going to call that P, okay? We're going to call that P. And so the focus to the origin is P, thus the distance from the origin to the directrix should be P. That is the definition of a parabola. Again, the distance between the focus and a point on the parabola, and a point on the parabola and the directrix should be equal. Thus, those two P values should be equal. Okay? So that is our definition of the parabola. Okay? So formulaically, how we describe them. Okay? So the two formulas we're going to use for them, okay, are going to be x squared equals 4py. There's the p. That's the same p we just drew in the problem. Okay, that's going to be if it's vertical. And then if it's horizontal, we're going to use the formula y squared equals 4px. That's going to be a horizontal. Okay, a horizontal parabola. All right, so those are the two formulas we'll use. Again, deriving them is really kind of tricky. I'm not sure it's worth our effort and time at this point. I want to jump into some problems so you can get a sense of how we actually graph these. So let's just jump right into it. I'm going to leave those formulas up there so we can see them. So the question is, it says, if the equation of the directrix is -4, what is the equation of the parabola and where's the focus? Okay, so it may actually help to draw this out, and then we can figure out the equation in a minute. Okay, so I'm going to draw my axes. And I know the directrix is x equals -4, so I'm going to draw a directrix, which you should always draw with a dotted line. I'm going to label it -4. Okay. And then I know the parabola is going to be centered at the origin. That's what we're doing right now. So I'm going to have a parabola that looks like this. We're only doing parabolas centered at the origin. So I know it's going to be centered there, and it's never going to cross the directrix. So if the directrix is in the negative territory, the parabola is going to go towards the positive territory. And I know my focus is going to be somewhere up here. Now again, let's think back to what we did above in that P, right? The P value here, right? P was the distance between the focus and the origin, and it was also the distance between the origin and the directrix. So if we scroll down here, what is the distance? What is this P distance right there? That should be 4, right? So then what should this distance be right here? That should also be 4, meaning this point, or the focus, must be 4, 0. Okay? So then it says, we have the focus. What is the equation of the parabola? Well, this is a sidewards or horizontal parabola. So I know in general my equation is y squared equals 4 times p times x. Well, what is the value of p? Well, we just found that to be 4. So my formula, if I substitute in 4 for p, should be 4 times 4x, which means my formula for the parabola should be y squared equals 16x. And you can just leave it, you don't have to solve for y, you can leave it as y squared equals 16x. Okay? I was just about to say, are there any questions? But you can't ask them right now. So hopefully there aren't any. If there are, maybe try rewinding and rewatching it and giving that a shot. All right, let's move on to problem number 2. Problem number 2 says, given x squared equals y, A, find the focus, B, find the directrix, and C, prove that the distance from 3, 9 to the directrix is the same as the distance from 3, 9 to the focus. All right, so let's maybe do this one in parts, and I would encourage you actually to pause the video for each letter and see if you get what I get. So I would encourage you for A to maybe draw a quick sketch of this. First, determine if it's horizontal or vertical. Draw a quick sketch. Draw the directrix. Actually, before we do that, I want you to actually just find the p-value. So ignore drawing the graph. Why don't you start with the equation and see if you can find the p-value in A, and that'll give you the focus. So pause the video, try finding the p-value, and then check back to see if you get the same thing I did. Okay, hopefully you paused it, and hopefully you've got something. Okay, let's see if you get the same thing I get. So it says find the focus, and I know the focus, okay, really is the p-value, right? It's really the p-value at this point. So I know in general my equation would be x squared equals 4py. That's just your general equation for a parabola, a horizontal parabola. And I know in this case, the specific equation is x squared equals y. And really I could write 1y if I wanted to, right? So the question is, how do we find the value of p? Well, guys, take a look at this. Right here. What should 4p be equal to? 4p is really just equal to 1. So what is the p-value here? The p-value is just 1/4. So meaning, if we were to do a quick graph of this, okay, oh, sorry, I think I said before this is a horizontal ellipse. Sorry, it's a vertical ellipse. Correct myself. A vertical parabola. I can't talk. Vertical parabola. So if I were to draw this, okay, and a p-value of 1/4, okay, I know it's the directrix, okay, since I have a positive x squared, it's going to be a positive parabola. My p-value, okay, is 0, 1/4, and my directrix is going to be negative 1/4. So I guess I did B here as well. Again, the distance between the focus and the origin and the directrix should be the same. So if P, again, you can think of P, and let me maybe write this specifically. Think of P as your focus. So if the focus is 0, 1/4, Okay, that must be the shape of my parabola, meaning the directrix is negative 1/4. Okay. Part C says prove that the distance from 3,9 to the directrix is the same as the distance from 3,9 to the focus. Again, I encourage you to pause the video and see if you can prove that, and then check back to see if you get the same answer I do. Okay, so you've paused it. Hopefully you've got some answer. See if you get the same thing I do. I know this graph, I'm just using this graph over here, has a point of 3, 9. What I'm trying to prove is that that distance in green is the same as that distance in green. Doesn't look the same, but it should be the same if I do it correctly. So if I have a vertical line from 3,9 to the directrix, finding the distance should be really easy. It really should just be, okay, 9 minus negative 1/4 equals, I'll use decimals, 9.25. That is your distance, okay, from 3,9 to directrix. Since the x values aren't changing, since it's a vertical line, I don't need to use the distance formula. I mean, you could use it, but you'll find that the x's cancel out to 0, and you're only worried about the y's. But to find the difference from the point to the focus, right, point to the focus, we need to use the distance formula. Oh boy, that is not a straight line. 3 minus 0 squared plus 9 minus 1/4 squared. Again, this distance between 3,9 and 0, 1/4. That, I'm going to just speed up the math here a little bit. Comes out to 85 and 7/16, or 9, sorry, 9/16, which would simplify to 9.25. If you used a calculator, that's fine. But you do need to use a distance formula to help prove that they are the same. All right, let's do one more together before we end this video. So the last one, it says in exercises 3 through 6, find the focus of the parabola and graph the parabola. So let's start out by finding the p-value, or finding the focus. Okay, so again, I know here's my equation, y equals 4x squared. If I have x squared, I know this is a vertical parabola, and I know it's always solved for x squared, so I need to solve for x squared by dividing both sides by 4, just to get it in a pattern I'm familiar with. So I have x squared equals 1/4 y, and again, just to repeat, okay, if you remember, okay, my general formula was x squared equals 4py. That must mean that 4p is equal to 1/4, or p is equal to 1/16. So if I'm making a graph of this, p again is my focus. Here is 0, 1/16. My parabola must be, right, shaped like that, which means if the focus is positive 1/16, my directrix must be negative 1/16. Okay, that's all you need to do for the parabola. Again, we're only doing parabolas centered at the origin, so that's all you need to worry about there, is graphing the focus, the directrix, and drawing me a parabola facing the right direction, okay, for the parabola. So again, just to repeat, okay, I'm going to scroll back up to the first page. Scroll back up, or maybe it's the, the second page. The two formulas we're going to use, okay, are x squared equals 4py, that's for verticals, y squared equals 4px as horizontals, okay. Remember that p, okay, p is the distance, right, between the focus and the origin, and also the origin to the directrix. So for example, if you know, like in problem 1 here, that the focus is 4, 0, you know that the directrix must be 4 away from the origin in the other direction, thus it's x equals -4, okay, and vice versa. In this problem, they gave us the directrix. It allowed us to find the focus, okay? So what I want you to do for homework, we've done 2, we've done 3, we have 4, 5, and 6, and then we've got 7 through 12 here. Why don't we try this? I'm thinking about the homework on the spot here. 4 through 6 here aren't that slow. why don't you guys try 4 through 12? Try 4 through 12. You can start that now. And then I want you to Zoom or FaceTime or whatever you want with your groups tonight and ask questions. I basically wanted to come up with a group consensus as to what the answers are, or at least to the best that you can. That way tomorrow in class, okay, hopefully that streamlines and minimizes the questions we have, because you've hopefully at least asked your questions first of your group, and maybe someone in your group could have answered the question. Okay, we want to minimize questions in class. Not that I don't want to hear from you, but I think that's going to be a little bit of a challenge sometimes, those questions, and making sure we have time to get to them all. So I want to make sure we try to minimize that if we can. So ask your group first, and if your group can't figure it out, or if you're not getting a satisfactory answer, feel free to ask it in class tomorrow, okay? Hopefully you've had a good day today, and we will see you tomorrow. Looking forward to it.